Hello student, myself Mr. Nitin Sasane. I am working as assistant professor, Department of Chemistry, Mahatma Phule AC College, Panvel. Today I am going to discuss with you the reducing reagents in organic chemistry. Now this is the content of my topic: introduction, Clemmensen reduction, Wolff-Tishner reduction, sodium borohydride, and lithium aluminum hydride. And finally, I am going to give the references. Next. Now, in introduction, the reducing reagent is an element or compound that loses an electron. Since reducing agent is losing electron, it is said to be oxidized. And in organic chemistry, basically, reduction is a process involving addition of oxygen, or reduction is a process involving removal of oxygen. Now, in this lecture, we are going to discuss reduction of carbonyl compounds to methylene by using two important reactions. First one is Clemmensen reduction, and second one is Wolff-Tishner reduction. And third one, it is a modification of Wolff-Tishner reduction that is called as Hung-Mindlon modification. Now, dear students, there are different reducing reagents. There are different reducing reagents, such as there are different reducing reagents. Some reducing reagents are some metal hydride reducing reagents, which include lithium aluminum hydride, diisobutyl aluminum hydride, and red aluminium. Now, beside these three, there are sodium borohydride, sodium cyanoborohydride, diborane, 9-BBN, and sodium triacid borohydride. Now, what is the long form of 9-BBN? BBN stands for boro-bicyclononane. And all these reagents are based on boron. Therefore, they are called as boron-based reagents. And these reagents based on the aluminium. Therefore, they are called as aluminium-based reagents, because when we look at the structure of these reagents, it is there is aluminum is there. Therefore, it is called as aluminium-based reagents. Now, beside metals, there are some non-metals which also act as a reducing reagents, such as non-metal-based reducing reagents and dissolving metal reductions. Now, when you see the periodic table, we know that in the periodic table, most of the elements are metals and very few elements are non-metals. So, some non-metals are also used as a reducing reagents. Now, some examples are here. First one is diamine. Second one is Hunt's synthesis. So, this NH2 is the functional group of diamine, and dihydropyridine is also act as a reducing reagent. Beside this, some dissolving metal reductions are also there, which involve zinc, lithium, sodium, and magnesium under neutral and acidic conditions. And very important reaction is Birch reduction, which is there, which involve lithium and sodium in presence of liquid ammonia and aromatic hydrocarbons. Now, dear students, as I told you earlier that in this lecture we are going to discuss two important reactions. First one is Clemmensen reduction, and second one is Wolff-Tishner reduction. In Clemmensen reduction, basically, this is the reaction condition. We are using zinc amalgam in presence of hydrochloric acid. And remember one important thing, in this Clemmensen reduction, this C double bond O group, that is carbonyl group, is converted into methylene. Yes or no? So, this is very important change. In Clemmensen reduction, carbonyl group is converted into methylene. And by using amalgamated zinc, the meaning of amalgamated zinc is zinc in presence of mercury is called as amalgamated zinc. Okay. Now, look at these different examples. This is a ketone, and in this ketone, this carbonyl group is converted into methylene. So, ketone after reduction is converted into alkane. Now, this is another example. It is a cyclic ketone, and look at here. This C double bond O group is converted into CH2. CH2 is the methylene. Another example, this is aldehyde, benzaldehyde. In this reaction also, this C double bond O group is converted into methylene. So in Clemmensen reduction, the very basic concept is C double bond O. By using ZnHgScl, it is converted into CH2. This reaction is called as Clemmensen reduction, and these are some examples of Clemmensen reduction reaction. Now this is alternative proposed mechanism which shows the electron addition. Next. Now dear students, another important reduction reaction is Wolff-Kishner reduction. And in Wolff-Kishner reduction, what we are using NH2NH2 in presence of NaOH. The NH2NH2 is called as hydrazine in presence of sodium hydroxide. And in Wolff-Kishner reduction also, this C double bond O group is converted into CH2. Okay, so what we understand in these two reactions, the application is same in both reaction. In Clemmensen reduction and in Wolff-Kishner reduction reaction, carbonyl group is converted into methylene. But in Wolff-Kishner, we are using NH2NH2, that is hydrazine in presence of sodium hydroxide. But in Clemmensen reduction, we are using ZnHg in presence of hydrochloric acid. Now look at here, this is benzaldehyde also. The application is same. C double bond O group is converted into CH2. Okay. So I mentioned here, in this reaction, carbonyl group of aldehydes and ketones, it is converted into methyl and methylene. Yes or no? So these two important reactions. This is another application. We are not going into detail the application part. Now, as I told you earlier, some metal hydrides also act as a reducing reagents. Now, in this case, look at here. Now, in metal hydrides also, there are different types. Some metal hydrides are boron-based metal hydrides, and some metal hydrides are aluminum-based metal hydrides. Okay. So, at the beginning, I was given the example of boron-based reagents and aluminum-based reagents. Once again, look at here. Sodium borohydride, sodium cyanoborohydride, diborane, these are the examples. Okay, one more, 9-boro-bicyclononane, sodium triacetoxyborohydride, these are the examples of boron-based reagents. On the other hand, lithium aluminum hydride, diisobutyl aluminum hydride, red aluminium, and lithium and potassium selectorite are the examples of aluminum-based reagents. Now, boron-based reagents. Now, this first reagent is sodium borohydride. The formula is NaBH4, and sodium borohydride is very specific. As I told you, it selectively reduces aldehydes and ketones to primary and secondary alcohols. So, my dear students, it is very important to note that some reducing agents are very selective. They selectively reduce specific groups. So, sodium borohydrides reduces only carbonyl group of aldehydes and ketones into primary and secondary alcohols. Look at here example. This is ester. One functional group is ester, another functional group is ketone. But in this case, ester group remains as it is, and this ketone undergoes reduction into the secondary alcohol. Yes or no? Now, another example, it contains two important functional groups. One is nitro and another one is ketone. But look at here, nitro group remains as it is, but ketone is reduced to secondary alcohol. Okay. This is another key example of ketone. Look at here, this ketone is reduced into the secondary alcohol. So very interesting. Sodium borohydride reduces alcohol into aldehydes and ketones into alcohol. This is mechanism. I will not go into detail of the mechanism part. These are the examples. Okay. Now, dear students, in tomorrow lecture, we will discuss the aluminum-based reagents in detail. Thank you for your patience listening.